Alright, let's move into problem number 39 now. So let's read out the problem. The problem talks about the integral right angles. If P is the perimeter of the right angle triangle with the integral length of sides A, B and C, there are exactly 3 solutions for P is equal to 120. Any other solutions? So what they are talking about, let's say we have a right angle triangle. Okay, that means there is one 90-degree angle of the triangle, and if A, B, C are three sides of this triangle, then we know by the Pythagorean theorem here A square plus B square is equal to C square. Okay, that's the Pythagorean theorem. And if you see, if you try with 20 square plus 48 square, it will be 52 square. So we can check this out. So what this says is if P perimeter value is equal to 120, then we have 3 solutions. Now we have to find out for the perimeter value of less than 1000 where this solution is maximum. That means for which P the maximum number of these combinations can be found. Okay, let's jump into the coding. Okay, so first what I'll do, I'll create a function called the Pythagorean norms. Okay, so let me create this function div Pythagorean norms. Then I'll take A, B and C. We just want to return whether A square plus B square is equal to C square or not. Okay, so I can just write this one line function that says return A square plus return A square plus B square is equal to C square. Okay, I think that's it. So we just need to check whether ABC is in the Pythagorean normal or not. Let's test it. Let's Pythagorean norm. Let's try, like, we know 3 square plus 4 square is equal to 5 square. Okay. Let's try 3, 4, 5. See, this is true. So if you just make it like 3, 4, 6, it is false. Okay. Now what I'm gonna do is I'll just okay, so what it says is, let's say for P is equal to P, the perimeter is equal to A plus B plus C, if that maximum value of P is equal to 1000, and we know in this combination, in this formula here, it's A is less than B and less than C. Okay, that's the condition. If that happens, then we can say one thing is A must be within 1 to 500. Actually, in fact, it will be less than 500. But we can say A cannot be greater than 500, because you know A plus B plus C is equal to 1000 as a maximum value. Therefore, we can create a loop and we can just try to find out all the combinations. Okay, all the combinations of A plus B plus C where A is varying from 1 to 500. Okay, and so yeah, let me create another loop. So I just want to create this combination of A, B and C where A plus B plus C is equal to 1000. So what do you mean by this? Let's create a list. Let me create a list of Python. Okay, I'll make it an empty list. Then what I'm going to do is I'll create a loop for A in range 500. Okay, and similarly we know B will also be with less than 500. Okay, and for B in range I can do B in range 500 as well, but you know there is this relationship A B is greater than A. So therefore I can start this from A. Okay, so I don't have to start from 0 again. Then I know that C is equal to square root of A square plus B square. A square plus B square to the power 0.5. That's the square root. To the power 5 or 0.5. Okay. Now here we need to check whether C is if C is a whole number, then we know this is a Pythagorean rule. Okay, so what do I mean by this? So we just check this. We know usually C will be fraction. If you take any A square plus B square and square root them, there will be fraction. The moment we get a whole number, then we know there is a Pythagorean triplet. Okay, so the check here is, I'll just say C. If C is equal to integer of C, that means if C is a whole number, then I'm going to append LSTP2, not append. Okay, here if I needed A, B, C combination, I could append A, B, C. But for our problem, we just care about the perimeter of it. Okay, so therefore, I don't worry about A, B, C combination. All I need to do is I need to worry about A plus B plus C. That's the perimeter. Okay, I'm just going to append the perimeter. So let me run this. Okay, this is range. Okay, let me run it. Run. Now let's see this list. So I have got this list. Okay, let me do one thing. I'll just make it as an integer so that we get all integers. Okay, so we got this. Now let's see how many numbers we got. So we got 950. Okay, let me just check on combination. Print A, B and C. Here we are getting 0, 0, 0. Okay, I think we need to exclude 0. That's the problem. Okay, now let's see, and now it looks fine. So yeah, we should not keep the 0 here. Because of 0 we are getting too many numbers. Now it's 455. Now if we look at these numbers, so yeah, we got this 455 numbers. So what is next is, now we have to find out what is the maximum value of perimeter for which the solution is maximized. That means there are maximum number. For example, our initial example, we had 3 solutions. We have to, for the perimeter P is equal to 120, we have to find out the maximum of P where the solution is maximized. So that means, therefore I need to create another loop just like that. Let's say I'll say maximum of solution, maximum of max P, let's say. Okay, I say max P is equal to 0, and then I say max of I is equal to 0. Then what I'll do is loop for I in range 2 to 1000, because I know we should not start from it, and triangle perimeter cannot be less than 2. Okay, so I'll try this. Then I'm just creating a count variable. Count will give us the maximum count. Okay, and here what I can do is simply like list, from list we just count of I. So this is a Python built-in function count. So if you just give this value, it will give you how many such number exist in your list. Okay, and then here what I'm doing is I'll just check if count is greater than max of P, then max of P is equal to count. That means I'm just keep track of the maximum count. Then I'm just saying max I is equal to I. Okay, let's run it. Okay, again range. Okay, run it. Now let's see the max of p. Max of p is this, and what is max of I? For which value of I this is maximized? This is 140. So I think this is confusing. It's not max of count. Okay, I should say like max of C, maximum count. Okay. Now if we do max of C is 8 and max of I is, so this max of I, this is the perimeter value. Okay, for this, that means for the value of 840 the solution is maximized where we got the 8 combinations. Okay, if you want to check for what values of ABC, well, that's not required, but if you wanted to do that, then we could actually save all this value here and figure out. Okay, now let's try with 840. Yes, our solution is correct. Thanks for watching. That's it for the current problem. Coming up next is problem number 40. Thanks again.